Hi, I'm Matthew from Nussknacker, and today I wanted to walk you through one of our scenarios available at demo.nussknacker.io. It's built to process bank transactions from a Kafka topic, detect unusually large transactions, and trigger alerts for potential fraud. Stick around till the end to see how easily you can adapt this scenario to new business requirements. Let's jump in and break down how this works step by step. Here is a high-level look at our scenario. We have two branches processing transactions from the Kafka topic called transactions. On the left, we focus on the individual transactions, while on the right, we aggregate transactions per customer over a 24-hour window. Each branch performs its own checks to decide whether to raise an alert or send a transaction for audit. The process starts with the Kafka source node, which ingests transactions from the transaction Kafka topic. Each message contains customer transaction details, automatically stored in the input variable, ready to be used throughout the scenario. And here's something cool. As we go through each node, you will notice that Nussknacker displays a small number at the bottom of each node. This number represents the real-time count of messages that have passed through that specific node, so you can get immediate feedback on how many events are being processed at each stage. The system updates these numbers continuously, helping you visualize the flow and performance of your scenario in real time. Let's get back to our scenario. In the left branch, we filter out transactions where the amount exceeds a threshold, in this case 1000. This is done using a filter node called check large transaction. The logic here checks if the transaction's amount is greater than 1000. If it passes, the flow continues to the next step, where we fetch customer data. Next, we use an enricher node to call an external OpenAPI service and fetch customer data based on the client ID. Nussknacker automatically detects and generates forms for external services like this. The customer data, such as their category, is stored in the customer data variable. This will help us decide whether to send an alert or take a further action. Now, based on the customer category, we have a switch node that directs the flow. If the customer belongs to the standard category, we raise an alert for the large transaction and send it to the alerts Kafka topic. Otherwise, we send a transaction to the audit topic for further investigation. On the right side, we aggregate transactions for each customer over a 24-hour period using the aggregate node called aggregate customer transactions. This node sums the transaction amounts for each customer within the given time window and stores it in the aggregated data variable. To add an extra layer of analysis, we run the aggregated transaction data through a machine learning model to assess the risk of dispute. The ML model takes the current transaction amount and the 24-hour sum and returns a risk score. This is done in the ML enricher node, and the result is stored in the ML result variable. Finally, we check if the dispute risk score exceeds 0.9 using another filter node. If it does, we raise an alert, sending the customer's 24-hour transaction sum and the risk score to the alerts Kafka topic. This helps flag suspicious activity for further review. Now, let's adapt the scenario to meet a new business requirement. Our goal is to send an audit report whenever a client performs 15 or more transactions within 24 hours period, regardless of the total amount. We already have the aggregated transaction data, which includes both the sum of transaction amounts and a count of transactions. We will reuse this data to add a new condition, checking if the number of transactions exceeds 15. First, we will add a split node to create a new parallel processing branch. Next, we will add a filter node. In this node, we will check if the transaction count from our aggregated data exceeds 15 using the following condition. If this condition is true, the flow will proceed to the next node. Let's now add the sync node to handle the audit report. We will configure it to send the following message to the audit topic. This way, anytime a client performs 15 or more transactions in 24 hours, an audit report will be automatically generated and sent to the audit topic. Once we have added the new logic, it's time to deploy the modified scenario. With just a click, Nussknacker will redeploy it in real time, and you can immediately start seeing how it performs. As the data flows through the scenario, the real-time counters at the bottom of each node will update, showing you how many events are processed. This makes it easy to track if the new audit rule is working as expected and how many transactions trigger an audit report. It's fast and intuitive way to validate your changes. And that's how you can build and modify a real-time parallel processing scenario in Nussknacker to detect large and potentially fraudulent transactions. We have used both simple filters and advanced machine learning models to process data in real time. If you want to try this out for yourself, check out Nussknacker and experiment with your own scenarios. You can sign up for the cloud version to save and deploy your scenarios. Thanks for watching! Be sure to like and subscribe for more tutorials on the real-time stream processing with Nussknacker. Bye!